I have a question for you. Can two blocks moving in parallel ever intersect in their paths? Well, the short answer is yes, but the reason why is shocking, and it has something to do with Galilean transformations. So let's start by creating two reference frames. The first one will be an inertial reference frame where we have given v1 to the first block and v2 to the second block. The next frame will be a reference frame that's moving at v0. This gives our blocks a reference velocity of v1 minus v0 and v2 minus v0 respectively. Now, let's call the distance between them the vector d. Cool. So let's see what happens at, say, time t0. We now have our reference equations as follows. First, r1 of t equals v1 minus v0 t, and 2, r2t equals v2 minus v0 t plus d, our displacement vector. When we set them equal to one another, v1 minus v0 t equals v2 minus v0 t plus d. And we do a little bit of simplification, the v0s will cancel each other out, and we get v1 minus v2 t equals d. So, since both v1 and v2 are velocity vectors, and d is a displacement vector, we now know that the only way for the equation to be valid is if the velocity and d vectors are parallel. And this can only happen if the blocks are directed in the same path. So, technically, there is a way for two blocks to cross paths when in parallel.